We're going to get started now. Welcome, everybody. We're so thrilled to have you here this evening on the East Coast or late afternoon on the West Coast. My name is Aaron Mertz. I'm the director of the Aspen Institute Science and Society program. The mission of the program is to raise public trust in science and to help foster a more diverse and a more engaged scientific workforce. And I think this event tonight really hits on both of those missions. I just want to give a quick background about how this event came to being. The program is guided by this rock star group of 20 individuals who are approaching science from all different angles. And one of them is playwright Lauren Gunderson. And she just wrote a fantastic play called The Catastrophist that she's going to talk about in a little bit, and reached out to see if we could put together an event that highlights the play, highlights different kinds of discussions about science and about society. And so that's the premise of our being here tonight. We're really hoping that this event humanizes the scientific endeavor for the audience. Instead of talking about scientific discovery itself, we're actually going to talk about a different kind of eureka moment, meaning when did people discover science as being a really amazing endeavor, activity, or initiative, to the point that these wonderful scientists we have with us here tonight devoted their lives and their careers to it. I'm going to turn it over to Ryan from the Roundhouse Theater, and he's going to talk a little bit about his work.
Good evening, everybody. I'm Ryan Roulette, Artistic Director of Roundhouse Theater in Bethesda. We are a theater for everyone, which enriches our audience through bold, outstanding theatrical and educational experiences that inspire empathy and demand conversation. And we are thrilled to be a part of this show in a year in which building public trust in science is literally a matter of life and death. We have been so pleased to co-produce The Catastrophist with our friends at Marin Theater Company. In profiling her husband, Nathan, Lauren has given us a glimpse into the passion that underlies and drives his incredible work. And tonight, with the thanks and leadership of the Aspen Institute, we'll get to hear the personal origin stories of some of the country's most interesting scientific minds. So, Aaron, thank you so much for putting this together. It's my pleasure now to pass it off to the director of The Catastrophist, my good friend, Jason Menedakis.
Hello, everyone. Thank you so much for being here. Aaron, thank you for hosting us. Ryan, thanks for being a part of this. My name is Jason Menedakis. I'm the Artistic Director at Marin Theater Company. And Marin Theater Company is located in Mill Valley in California, just north of San Francisco. And we are a theater that is committed and devoted to new works and new American playwrights. And Lauren is our playwright in residence and has been our playwright in residence for 5 years. And when the pandemic started to lock down the country, we realized that we needed to find a way to create art that was going to respond to the immediate moment that we were in. And Lauren and I have an ongoing conversation about her work, how her work relating to our work as our playwright in residence. And we started talking about ways that she might actually create a piece within the pandemic that we would be able to actually film, a piece that lives somewhere in the virtual realm, somewhere between live theater and film, somewhere between something that you would come see in a theater and something that you would see through a medium such as your computer or your smart TV or your phone. And this is what came out of that. And literally this conversation started about 10 months ago now. And it's just kind of amazing that we started that conversation. Lauren ran with the idea. I'll let her tell you exactly how that all came up. But she has spent a good part of this pandemic year writing this story. And then back in November, we went into rehearsals at the right as Thanksgiving, right around that time. And we rehearsed the play for 3 weeks virtually over Zoom. And then we went into the theater for 1 week, 5 days, 2 days of spacing and 3 days of filming. And that's how we created the work that you hopefully have seen or that you will shortly see, that is all about Dr. Nathan Wolfe and the moment that we're in and the moment that led up to this moment. So I am now very, very pleased to introduce one of the country's leading playwrights and, as American theater likes to say, the most produced living playwright in America, Lauren Gunderson.
Hi, everyone. It's such a pleasure to be here. Thank you for joining us tonight. So my job is to tell you a little bit about the play that kind of launched this conversation, The Catastrophist, which is based on conversations and an artistic version of Dr. Nathan Wolfe, who's sitting right here, my husband, virologist, pandemic specialist. And, you know, the real reason why we're here and the reason why I reached out to Aaron is because what excites me the most is the part of the science's story that I feel is most missing, which is the humanity, as Aaron said. I'm most interested in the heart and the soul and the life behind the brain, behind these big ideas. And that was part of the reason for writing the play, The Catastrophist, which is really a play that talks about science and about scientists, but also it's about a father, it's about a son, it's about a marriage, it's about how art and science creatively dance with each other. And so I wanted to have that be the core question that brings us all together. And bring us all together means something so special to me because the people, the 5 amazing brains that you will see tonight represent some of the greatest minds in microbiology and virology and in the sciences right now. So I could not be more thankful and grateful to Nita, Namanji, Ben-Hur, Nahid, and Nathan for joining us tonight to hear a little bit about how you found the passion that is so riveting to me and hopefully more and more riveting and important and guiding to so many people out there. And the truth is, although I wrote a play about Nathan, any of these scientists that you are about to see could and should have a play written about them. So for the artists out there, the playwrights, this is free inspiration for your next play. So thank you so much. And I am thrilled about this upcoming conversation. Can't wait.
There we go. Thank you, Lauren. The format for this evening will be rotating paired conversations between 2 of our expert scientists at a time. And so we're going to have one scientist interview the next one, and then the first one will drop off, and then a third one will come on and be interviewed by the second. So it's very dynamic, it moves fast, and we're hoping to have some really interesting conversations with these virologists, immunologists, and other pandemic experts. So one thing to note is that we're having some trouble with the chat feature. So what I'm seeing from my colleagues is that you can tweet the questions to us. Jasmine, do you want to come on and say where they can do so?
Hi there, everyone. Yeah, sorry for the technical difficulties. Usually there's a live chat box in YouTube. And to get around that, but to still feel like this is a little bit immediate, you can tweet the questions to, do you want to say the Aspen Institute's?
No,
Twitter?
Go for yours, please.
Okay, so it is, I will put it on screen as well. It is at RHT_Roundhouse. And we will feed the questions in that way because these are some brilliant panelists and I'm sure everyone's going to want to ask them questions tonight. So sorry that the chat isn't working, but please do pick up your phone for a second and send a quick tweet if you want to have your questions answered at the end of tonight's event.
Thanks, Jasmine. So please, you can tweet the questions throughout. We'll be doing a dedicated Q&A at the end, but bringing back all 5 of our experts for that discussion. So first, I'd like to introduce Nathan Wolfe. He is a virologist, an entrepreneur, and the founder and chair of Metabiota. It's a data analytics company focused on epidemic risk. He's the author of The Viral Storm, and he was named one of the most 100 influential people in the world by Time Magazine. And joining him in conversation will be Ben-Hur Lee, professor of microbiology from the Icahn School of Medicine at Mount Sinai. His laboratory focuses on how viruses co-opt basic cell biological processes to complete their life cycle and the myriad strategies used by viruses to propagate themselves. So let's bring them both on for our first conversation.
Wonderful. Well, first of all, let me thank the Aspen Institute for pulling this together. I've been fortunate to participate in Aspen Institute programs over the years. And I don't believe the organizers knew that Ben-Hur Lee and I, about 12 to 15 years ago, were colleagues at UCLA and collaborators. And we were just talking backstage about one of the pieces of work that we did jointly, which is a very exciting one. So bravo to the organizers. Also, because I think what's quite interesting is our collaboration helps to illustrate some of the diversity you see in scientists. So my role in that science was really as a field virologist, someone whose job was to go out and obtain specimens that could tell us interesting features. And I'll tell you a little bit about the science, and maybe Ben-Hur can do more. And I know Ben-Hur really as kind of not only a deeply talented and knowledgeable virologist, but also a magician in the laboratory who was capable of putting together tools that permit to answer questions that we didn't think we would. And maybe it is just worth taking a minute to tell you all about the science we did. So among the viruses out there, coronaviruses, retroviruses, filoviruses like Ebola, that is of interest as potential future pandemics is a group called the henipaviruses, including Nipah, which had an important outbreak in Malaysia some years ago. And what we did is we said, well, look, you have bats in Africa, which is where I was based at the time. Why don't we look to see if any of the individuals who are hunting these bats are actually exposed to this? Now, the problem is, unlike some viruses like retroviruses, which stay in people for long periods of time, the Nipah virus, it comes, it infects people, these henipaviruses, and then they will no longer be present. Now, Ben-Hur had the capacity to look at evidence of antibodies from years ago, and to make a long story short, we did just that. And what we found was that there was evidence of henipavirus serology, particularly among the individuals who hunted bats. And so that was a smoking gun that, in fact, the exposure to these animals was leading viruses to cross over. So maybe that's just a little bit of a long context, but I think quite topical to give you a sense of. And it's been years since I've had a chance to talk to Ben-Hur, so I have a number of questions for him, but I will try to stick to the theme, at least for the first question, but then I may take the liberty of this position to ask some just more general questions that the audience may find of interest. So given Ben-Hur, I don't really know your origin story of how you became a scientist. I think of you as, just a deeply skilled, talented, and devoted, laboratory scientist who really developed new methods, as well as a virologist. But I would love to hear, your backstory of how you came to viruses, and what really, how that emerged, and as well as how you came to the sort of technical work that you pioneered.
Yeah, well, I do want to talk about science too, but actually, I recently wrote sort of like a opinion piece for PLOS Pathogens, and I titled it "The Quest for Good Explanations," and that's from one of the physicists' books that to be a scientist, I think some astronauts be politicians, and you can't really explain that except for a sense of curiosity, a deep sense of curiosity about nature. And I find that in physics. So when I grew up in Singapore, it was just study your books, and Asian parents want all their children to become doctors or engineers, right? There's no second choice. And so we weren't given the chance to explore. And when I came at 17 to Santa Clara, I grabbed the first opportunity to research, and it was in the Bay Area, and it was at NASA, Ames, exobiology branch, all these romantic sounding things to a 17-year-old, and we were just studying like the most obscure things, cyanobacteria, which are blue-green algae found in like extremely salty lakes in Israel, and figuring out how they metabolize lipids. So why does astrobiology, like NASA, study that? It's because they're like molecular fossils, because they evolved at a time where they made the oxygen concentrations. They were trying to figure out whether there was a pathway of metabolizing these lipids that doesn't depend on oxygen, and they were using these oxygen analyzers that they use from the Apollo moon missions. There's all these romantic things, that made my eyes wide open. And all I was doing was day in and day out was just like doing the same assay and extracting lipids. But to me, I'll get up at 5 in the morning just so that I can have the results ready when my mentor came in. And so that's an important thing also to have mentors, to sort of like make things appeal to you. And from then on, I never lost the passion from medical school. You see, I don't have a PhD. I don't have an MD. By the way, I'm only one in there. So I always feel like a carpetbagger, talk about imposter syndrome. But because parents want you to go, they don't understand this PhD thing. My parents was willing to pay for good, but I tricked them. So I went to medical school at Yale because it was the only school that required a thesis for graduation. And it was a really big deal at Yale. I took a year off. I had a Howard Hughes fellowship, and I did pure research. And my mentor, sat down with me for 20 minutes every morning to make. I was just a medical student. I mean, I don't do that with my students. So I've been lucky all the time, not only to have that innate sense of curiosity, support by mentors that I had, and then it just went on from there, because once you get good training, you felt like you could actually, when you delve deeply into stuff, all scientists say this, that at some point and time, you make a thing that literally you're the only person in the world at that time to know that, when something comes out, like in the work that I did for you, honestly, I didn't think anything was come out of it. I was like, just be careful, but he was really into bats, as and like hunted down, from a bat serum, and but it's a great collaboration. Then you find, like, as you move and mature into technique, to reach out to people that you don't know everything in the world, and nowadays you can't do everything by just your field. So you reach out to like people like Nathan was there, that had like precious archival sample, and have to figure out how these only whatever it was, 50 microliters, and that's it in the entire world, because you can't go back and get those samples again. How do you make sure you save enough to do the final experiments? That's part of the fun of it. And data comes back and we have eureka moments, but science, I think, builds on itself, and when you have good collaborators and things begin to working. But and actually, scientists also need to have a great tolerance for failure, I think. That many times it doesn't work, right? And we have to have very thick skin. And that's true. But we live for that 1% of the time that things do work. And, you're excited about that. So that might be still naive when I came, just because now they're funding in times that are not as good. You think about those days where you're still sort of like idealistic about how science works.
So Ben-Hur, I would also say it's a little bit unfair, but it also is useful for the audience to get a sense of how this science works together. So I had to, and of course this is very collaborative work, but spent years trying to get the specimen, and then there was the archive, waiting for the right scientist who had the appropriate technique. And then, of course, Ben-Hur gets the eureka moment, and for me, it's a phone call saying, we got it. And if I remember correctly, Ben-Hur, it was me constantly saying, what's going on? Is there results with the specimens? Is there results with the specimens? Endlessly. But it was... Yes. I really have to hand it to Ben-Hur. It was a very elegant result. Like, it really was a very clear signal that those individuals had more exposure. So it really is a testament to this tool that we didn't know for sure would work in that context. I think I may have the chance to ask one more question. And it's not necessarily about your origins, but I think it would just be, I would be quite curious about it, which is, look, part of what you and I did together and what we were a part of a community thinking about is, what are the techniques necessary to make the world safe against pandemics and to try to understand pandemics in a way before they occur. Now that it's been 15 years since I think we did our work together, and we've experienced the most substantive pandemic of our time. I mean, I think we could think about HIV as well, but let's set that aside. That was a little bit before our time as a scientists. But what do you think now for post-COVID world will be the sort of most important technology that people are not discussing? Because I think that's exactly where I want to know from you, to making the world safer from future pandemics.
You cut off there at the last moment. I think that it was a bit choppy.
The critical one. Yeah. So what technology that's either one that you're working on, that you've heard of, that you've been thinking about, that now we've experienced this sort of massive pandemic and we've been able to see the nuance of it and the specifics of it. What technology that's not being discussed will be most important sort of in a post-COVID world for us being able to think about and mitigate the risk from future pandemics?
Yeah, I think we have to invest in what thing to help, prevent things before they occur, or like to build up systems that, prediction is always a risky affair. But I know and it's hard work, but it's hard work because you need to build up the data. So it's necessary to gather the data and to put the best resources out there. So we couldn't say this 10 years ago, but now you have nanopore sequencing that works on a thumb drive that you can enter the field and actually do genomic sequencing of viruses that's out there. And if you hit the right populations and sentinels and animals, right, and build a new data set, and Nita knows much more about this than me, and expert systems to pull together to maybe to see trends that are developing before they occurred. So hindsight is always 2020, but it's not as if we did not know that this would happen, because viruses and bats just waiting to jump up, and across, and when it did, also there has to be something to say about how the world needs to have a more transparent and system. The politics involved in this current pandemic just really showed that the virus don't need visas to cross borders, right? But we human beings do, and you realize that we can't catch up as fast as the virus to wake us up to as a world community, I think.
Hear, hear. And I will, in order to be timely, that was a perfect sort of end to our bit. I will pass it on to you and my colleague, Nita Madhav, the CEO of Metabiota. Thanks so much.
Talk to you later.
Welcome. We're going to have Nita Madhav next. She's an epidemiologist, a risk modeler, and CEO of Metabiota. It's a company that specializes in microbiological research, products, and services. Her team works on models that predict epidemiological preparedness and readiness of economies to absorb losses experienced in extreme events. So definitely lots of relevance to COVID and many other arenas. Nita?
Hello, and it's great to be here today, and I want to thank the organizers and the Aspen Institute for having me.
Well, hi, Nita. It's nice to finally meet you, because as I wrote to you in the early emails, I snuck your name in because I was talking to you next, and we know a lot of people in common, obviously. But just noticing now that you're CEO of Metabiota, but you were doing, you got certification in model predictions, and you're working this originally for years. You were generating statistical models for to quantify pandemic risks and other health risks, and this was before it was fashionable, because now it's like everyone is trying to do this, right? And in terms of origin, so how did you gravitate towards that work in the first place, or even before then? Why did you go into this field that you did?
Well, I can point really to one thing that happened when I was actually in the 7th grade. that's when I decided I wanted to be an epidemiologist. So
I couldn't pronounce that word in 7th grade.
What?
I said I couldn't pronounce that word in 7th grade.
Well, I first learned about it from a children's book I read called Medical Mysteries, 6 Deadly Cases. That actually, I ordered it through, you get those school catalogs where you can order the books from. And so I had already been interested in medicine and science, and this looked like an interesting book. And then when I found out that you can actually solve mysteries as part of the medical field, that sounded very interesting to me. So, the stories followed different, CDC epidemiologists and state health officials who were investigating outbreaks, and kind of wrote it in a way that was pieced it together as really like a mystery, a detective mystery story. So that's kind of how I got interested in that. And when I was talking to my parents about, I want to be an epidemiologist, they said, okay, is it a doctor or an engineer? Because I had that as well, a lot of that, and kind of thought, okay, well, maybe it's closer to being a doctor. You could do it with a doctorate in medicine, and then through while I was kind of looking into this idea, I actually interned with the Harris County, Texas Health Department when I was in high school to really, get some hands-on experience. And that's when I thought, wow, this is really exciting. And it was very interesting. So then I kind of tried to steer my undergraduate work. I did that in ecology and evolutionary biology. And that's when I really started to understand that what I was truly interested in were these really large scale questions. How do diseases impact populations? How do we, as a society collectively handle these risks? At that point was when, I started working on Lyme disease research and looking at how the interplay between different hosts of the ticks and in humans all kind of interacted together, and that's when I found out that computational modeling is such an effective tool for understanding these large scale processes. So that's when I really started to get into programming and data science, and kind of went on that trajectory. And then that's when, after that, I actually did some field work doing research trapping mice in forests and things like that to understand better, like get that experience and understand kind of on the ground how it worked. And then after that, I did my master's in public health and epidemiology at Emory. And that's, really kind of what set off, I was like, okay, now I'm ready to go be an epidemiologist. I'm so excited. I'm gonna go do that. And then life took kind of an interesting turn for me, because I needed to move to Massachusetts, because that's where my then fiance and now husband lived. And I said, well, okay, there's a few options here, but I need to get there fast. I looked into a few different jobs, and I kind of did something that really surprised me, which was I decided to take a job with a risk modeling company that at that time didn't have very much to do with epidemiology or anything like that, and kind of learned a bit about how the insurance industry works with catastrophic risks and catastrophe modeling. And then at that point is when it was actually around the time when the 2009 pandemic happened, the H1N1 swine flu. And that's when the company decided, oh, well, epidemics, those are risks too. And then we started working on how to apply some of the techniques that are used in that industry to better anticipate what sort of risks could be present from epidemics and pandemics. And then, not long after that, I moved over to Metabiota and took over the data science role there, and suddenly found myself as CEO about 1.5 years ago. So that's kind of the journey that I followed, but it's taken quite a few twists and turns.
I know you've been a big proponent of, you said you were a data scientist, and very impressed because I'm not a quantitative person myself, and I know it's hard to put lots of data sets together, and it seems like for people who are not into it, to be able to see patterns of big data sets is not a trivial thing to do. So do you think that we're better positioned now in terms of with AI and neural networks and things that can learn? Because I hear just from a lay point, when you get a good algorithm going, sometimes you get that, but you don't know how the program gets there. Is that what we are looking at to gather enough data for you guys to make better predictions and about risk?
Well, that's a really good question, and I think there's a few things that we can think about there. So first of all, data is important. We need that in order to use it to understand the world and to make the predictions, as you noted. But the quality of the data is very important. If you have bad data or garbage in, garbage out. So even though we may, if we're gathering a large quantity of data, there also has to be quality there. And then understanding how to kind of piece it together, like you said, sometimes it's not clear how to find these patterns. And I do think some of these tools and techniques that are now being developed and becoming more mainstream, I think they can be extremely helpful. They can kind of be an extension of what human intelligence can do. But I think it can also be a bit of a double-edged sword, because sometimes you still need that human element to help guide how the process works. We use a lot of human in the loop, so to speak, and looking at epidemic data. I think there's still ways to go with trying to standardize data when it comes to epidemics. We look at data from many different countries and areas, and it's surprising how little standardization there is in the data that are coming out of these various places. So I think there is something to be said about how much we can do with data now, but I think that the key issue is the data itself.
Yeah. Well, I see I have 2 minutes, so maybe there's one last question. And since you became CEO of Metabiota, and it's a company that's obviously involved in trying to, I guess, these what is it the best about your job now that gets you up in the morning, and both as a scientist and a manager? I mean, it sounds like a very unique position to be in, because for audiences that don't know what Metabiota does, I mean, you guys do really important.
Yeah, I mean, it really is the mission of the company that gets me up in the morning. Our mission is to make the world more resilient to epidemics. It's something that, when Nathan founded the company in 2008, that was, the track we wanted to be on. So it's been, a long journey, and I think we really believe the whole team, in fact, is very committed to this mission, and that's what gets me out of bed. But it is using a different part of the brain every day, but maybe not quite so different, because a lot of what you're doing when we're building data science products or trying to build new algorithms, a lot of it you can kind of think of people as something where you can also build some algorithms in. So there's just maybe more similarities than it might first seem.
Well, thank you very much. I think to keep on time, I'll give the feedback, and maybe you can carry on the conversation with the next one down the line. Thank you, Anita.
All right, thank you.
Great, thank you. Now we're going to welcome Nahid Badalia. She is the medical director of the Special Pathogens Unit at Boston Medical Center and associate professor in the section of infectious diseases at Boston University School of Medicine. She has vast experience in healthcare response to various pathogens: Ebola, H1N1, Zika, Lassa fever, and COVID-19 from local to global levels. Welcome.
Hi, thanks so much, Aaron, and thanks Aspen Institute for having me, and Nita, thanks in advance for the conversation.
Yeah, I'm very excited to be here speaking to you today. It's great to meet you, and really appreciate all of the work that you've been doing for many, many years. Kind of in the same vein as how the others have kicked it off, I thought it would be great to hear a bit more about how you got started in this field.
Yeah, it's sort of an interesting, there are common threads, right? We were all pressured whether we're going to be doctors or engineers, by our families. And it's interesting, in my path of rebelling against not being a doctor, I found every other thing that I was interested in had an element of science in it. I ended up being a doctor, as you can tell. But I think the thing that brings all of us to science fields, and I'm going to butcher and paraphrase this quote from T.H.S. Huxley, which is like the question of all questions, right? The problem that underlies everything else is man's understanding of his position in the nature of things and in the universe. And that's what science is to me. It's our understanding of how we fit with everything else around us. And for me, the real love, I think, for science came from my love of medicine, and particularly infectious diseases. I grew up in a lot of different countries. We moved to the US when I was 13, and I was born in India. We lived in Saudi Arabia and then in Sweden, and we moved here when I was 13. And a huge part of that experience was looking at inequities in healthcare systems and looking at how diseases play out, and particularly infectious diseases, because they soak up the canvas of our culture. They play out against the background of our economic systems, our political beliefs, and they're a mirror to us, and I think I knew pretty early. I think I might have read like The Coming Plague or something in college, and I knew pretty early I wanted to do infectious diseases. But I was always torn, and you could say I'm still a conflicted scientist, because I was torn about whether to work in the sciences or to actually work on the inequities and those aspects of it that are part of the international affairs system or the economic system. And I think that's a theme that followed me and has followed me for the rest of my life. So I rebelled, decided I wasn't going to apply to medical school, and I worked for a year after college at Oxfam America. There was this big grant from Gates Foundation that they had gotten to do civic engagement of youth, particularly around global health and global economic justice. And I was this 21-year-old that was driving around the country and putting together this hunger banquets. So Oxfam America is this economic development organization, and they have this tool called the Hunger Banquet that allows people to learn about the inequities, where everybody buys a ticket for dinner. And when you show up, 85% of the people end up on the floor sharing a plate. And then 15% of the people, 14% of the people are on a table with rice and beans. And then 1% end up on the table. And it sort of shows the economic injustice. And throughout that year, I remember sort of going back and forth about whether I was going to go to medicine and pursue this through a path of science, or if I was going to stay within this path, which was going to allow me to sort of look more at policy. And I went to medical school, did actually a simultaneous master's in international affairs at the Fletcher School. Again, sort of sticking with like, do I do this now? Do I go into international affairs? I ended up working at the UN for the summer. Again, had the same question: do I go into medicine? Do I do international affairs? And then I think what struck me is that in the end, all the experiences that I had through medical training, I volunteered, I think, in Nicaragua and Cuba and a bunch of different places. Huge part of what made me realize as an outstanding issue is that part of why many diseases remain diseases of poverty is because we don't expend the energy in answering the scientific questions around what causes them, how to prevent them, what treatments are available, what causes the severity of disease in some people versus others. There are neglected tropical diseases because we neglect them. And I think that sealed my sort of idea that this is the path that I would go down. And it remains so. Actually, I did my fellowship and ended up, you were talking about H1N1. I was finishing up my infectious diseases fellowship in New York City and, trying to decide how I was going to shape my path forward, because I'd done health security work, within my international affairs stuff in the past. And when H1N1 hit, it became so perfect, because the work that I needed to do was how do we take healthcare systems and prepare them so that a hazard does not become a disaster. And the hazard here are these emerging infectious diseases. And it also has become clear, because to me, after that experience in New York, I ended up taking this job here in Boston that I've a decade or 11 years later, I'm still here. And what I do is, for my day job, I run a biocontainment care unit. It's a specialized unit to take care of people with emerging infectious diseases. And the theory behind this is that, you need to have special containment features to keep healthcare workers safe, but also the understanding that when it comes to these new diseases, you can't separate research and patient care, because the first 100 patients teach you about the next one. The first 100 patients and the science you learn from that help improve the guidelines, help improve our understanding of natural history. But the biggest change, I think the thing that drives me now more than anything else, and sort of has solidified to me this path forward, is during 2013, 2016 Ebola epidemic. I was seconded by Boston University, first to WHO and then to Partners in Health, to work as an Ebola treatment unit physician in Sierra Leone. And worked, went down there in August of 2014, and then again 3 more times after that, working in ETU and then directing in ETU later in the course of this time. And it is a full stop in my story. It is the thing that highlighted the rest of the world mission for me, which was, this was a period of time that I lost 50% of my patients. I tell the story when I come back where in August of 2014, there were 4 of us working in Ebola treatment units. And when they brought the some of the Americans back, you talk about the experience that they had, the care here. We had 4 people taking care of about 100 Ebola patients in Sierra Leone. At Emory, which is one of the centers that received people, they had 100 healthcare workers taking care of 1 patient. And it really outlines, when we talk about mortality from these emerging infectious diseases, so much of it is ingrained in where you end up being born and what healthcare systems you encounter. But beyond that, our understanding of these diseases, sometimes we say Ebola has like 90% mortality. I think that story highlights to you, Ebola doesn't naturally have 90% mortality. Ebola's mortality is 90% because it is infused with all the other realities of how people seek care, what access they have to care. And so after that experience, I've sort of continued working both here and abroad. I serve as a clinical lead of a viral hemorrhagic fevers clinical unit in Uganda that's funded by Department of Defense, which is at the border of DRC. And our goal there, my goal there, has been to bring the same level of care that we have here for viral hemorrhagic fevers to there, and to improve sort of quality of care. Because how can we even answer the questions of whether drugs work or not when standard of care is not the same, or at least similar in these different places? So Lauren started off this conversation. It's so funny. I'll stop with this, but she started this conversation calling us great minds. And I was going to say, I don't think of myself as a great mind. If I were to use a definer for myself, I would say I'm a pissed off woman with a mission, and that's how I feel in terms of my engagement in science. It is the understanding that I don't want science to be the reason why the mortality is so different between these two places. And that's the goal that drives me.
Wow, that's really inspiring to hear. And, I think I see a lot of parallels as well to the stories with my own and others who've talked today. I think it is something that we've also looked at a bit, which is, really there are these underlying health system issues, and they really get exacerbated in any sort of situation like an emergent event or a pandemic. And so I was wondering if you maybe, since we have a bit more time, could say a little bit more about, what do you think needs to happen to improve these health systems?
Yeah, some of the work actually started after Ebola, right? So a bunch of work went into Global Health Security Agenda, this initiative that's, I think at this point, 90 something countries. And the goal of that was to help identify in different health systems what the gaps are. And it's interesting, the gap they identified in the US healthcare system is very much what came back to bite us, which is our inability to collect data, in real time, share that with outbreak, analytics. You're shaking your head because I know this is your field, so you know this already.
Yeah.
The work that was done by CEPI, which is the Coalition for Epidemic Prevention Innovation, which is identifying, and funding therapeutics for emerging pathogens that are on WHO's priority list drugs. So some of the work is being done. I do think that there are new challenges that this pandemic identified. A big one of which is how much leadership matters, and how powerful disinformation is. And my hope is that after this pandemic ends, that we focus on, we've always said this, right, in pandemic preparedness, that we seem to go from cycles of panic and neglect. and you've heard this. And what I hope happens is that this is a lesson. This is what drives home the fact that we disconnect funding for all of our work, the type of work that we do and the type of work that others do to keep our communities from taking a hazard and turning them into disasters, right? All the fire breakers, let's invest in those. Maybe we can disconnect that from the political cycle. I hope that's the lesson that comes out of it.
Yeah, it's a great point. I think we see over and over again that early action, preventive action is really the key here before things get so large that it really does take a significant amount of resources and an untold cost, human and economic. So, completely in agreement here with you on all of the points that you made. I think it's also really important to note the dimensions of the political aspects, the information sources, and one thing that we've also seen is that there's really a need for collaboration with, not just scientists, epidemiologists, but also social scientists, and, bringing together a lot of these different fields to understand these kind of whole system issues that we're seeing.
Yeah, and ethics. I mean, I feel like, this came up during Ebola, and it certainly comes up now, and ethics as it relates to, how do you deal with emerging data in terms of making public health policies when you have this emerging shifting landscape of knowledge? And then also in terms of simple things like, we had to deal with patients or visitors not being able to go to see their dying family members in hospitals, the ethics of infection control, or ethics of access of all of those things that are not proper science in terms of biological sciences, but they impact outcomes for both society and for patients. The only thing I'll end is that we have a lot of work ahead, and I think the one thing this pandemic, I hope the next realization we come to is how tied we are globally. Right now, there's so much focus on the U.S. and I'm so glad that we rejoined the WHO. And I just heard today that the Biden administration is donating money to COVAX, which is an effort to try to get vaccines out to the rest of the world. Because by doing that, we ensure we don't get new variants of this virus, and by doing that, we ensure that there's a report, I think, from RAND Europe that says that vaccine nationalism could cost the global economy $3.4 trillion. And so ensuring, and this is me again, my conflicting sides of policy and economics and science, but truly those things are tied, because look, there was that tension throughout this pandemic too. How do we balance safety and science and public health with economic survival, right? And that's always going to be an ongoing struggle.
Mm-hmm. Yeah, absolutely. And so I think we're at time. So I want to thank you again and really enjoy the conversation today.
Thanks, Nita.
Thank you. It's a great pleasure now to welcome Namanje Bumpus. She is the E.K. Marshall and Thomas H. Marin Professor and Director of the Department of Pharmacology at Johns Hopkins University. Her research seeks to mechanistically define the role of drug metabolism in antiviral drug outcomes.
Hi, Dr. Bumpus. How are you?
Hi, good to meet you. Very interesting hearing about your origin and your work. That was great.
I want to start by thanking you for your work, because your work makes the lives of my HIV patients easier. And so thank you for that. And I will start off with the same questions that others posed, which is, what is your origin story in science? What inspired you to go into this field?
Yeah, so I think for me, there's a lot of overlap, but maybe I'll start where I'm a little bit different. So my dad was a professional boxer. He was managed by Joe Frazier. And I grew up really in that world, in sports and boxing. I had my first boxing lesson at 2. And my older brother and younger sister, we boxed through childhood, through our teenage years. My mom was in special education. When my dad retired from boxing, he opened his own gym and coached fighters. He actually coached thousands of people. And
Wow.
so I think the two of them, that's where I really got my love for teaching. And I'm a scientist, but central to being a scientist really is, loving teaching, being a mentor and passing on information. But with them, they really encouraged my siblings to explore what we'd want to do. There was really no pressure one way or another. So there was real exploration. Really, the only expectations were we had to work hard. That was the boxing origin. We'd work hard. It had to involve education, and it had to be centered on helping our community. My family also has always been very active in social justice and civil rights for generations. And growing up, we never actually were asked, what do you want to be when you grow up? Because often that turns into, how much money do you want to make? What title do you want? It was always, what will you do when you grow up to contribute to the world, contribute to your community? So I found that science was my way to contribute. So early on, like all of us, I liked understanding how things worked. I liked taking a bean and putting it in a wet paper towel and watching it sprout. How does that happen? My parents ended up getting me a chemistry set for the holiday, worked through it, loved it, and was really hooked. I wrote a letter to a scientific society when I was in elementary school. So this was pre, having my own email. So it was a handwritten letter, went to the library to get their address, and they sent me back brochures about what chemists do. And I was hooked. I really thought that was something that I wanted to do, a way to help my community, but do something that I liked, work on medicines. So I went through high school, focused on science, went to college, majored in science, started thinking, okay, what area? Found pharmacology, the biology of drugs, discovering and developing drugs. And I thought that, working on medicines, using that love of chemistry was a way to really contribute to my community. As you mentioned, I work on HIV drugs primarily, and I really chose that because being a Black woman, we're disproportionately impacted. So I thought that there was a way that I could do something tangible there as well. So I've stuck with it ever since. And as I mentioned, it's the love of science, but it's also that love of teaching, which is what really keeps me in the university setting, getting to watch the students have their own various eureka moments, I think is the most fulfilling part of what I do.
Dr. Muppets, I work on one of the things that's so close to me, and I would love to hear your thoughts about this, is particularly for some of the, the countries that I have collaborators in Liberia and Uganda, as I mentioned, and a huge part of the story that I hear from my collaborators, in a lot of communities of color, not just here, but also abroad, is how to be. A great story that I heard was David Satcher, the Surgeon General, in the past has talked about, it's not just where you sit on the table, but what you bring to it. And to me, in science, agenda setting, research agenda setting is such a big part of how we move forward with more equitable science, and the majority of my work is global. And I've always felt like, there's a huge gap in letting scientists from low and middle income countries help set the agenda. I think that's changing a little bit. Do you feel that something similar exists here in the US with our communities of color?
Certainly. I think that the, lack of representation has an impact. And so, with around COVID, there's been wonderful discussion, I think, about the need for diversification, whether it's clinical trials or, our healthcare professionals. Certainly, we need to diversify physicians and nurses and all the frontline folks. But I think what's missing from the conversation are the scientists, because you mentioned some of the agenda setting. Before a physician has a drug they even prescribed to somebody, people worked on that. Scientists, discovered the target. What is the drug going to act on? Made the drug, designed the studies from the earliest, in a petri dish and a test tube up through the first in human. So having, I think, diverse voices at the table not only impacts the diseases we're going to look at. Like you said, we have neglected diseases because no one's investigating them, right? So diversifying science is key for improving and enhancing even what we decide to study, what we prioritize, and then the lens through which we look at it. When we're thinking about how different people might respond, the range of responses we might see in people, we need folks at the table who are going to keep that in mind and think about various communities. So I think it's a piece that's often missed in this diversification discussion that is very, very important.
Are there things that you wish are there things that you wish that you had known before this pandemic started in terms of your career that you could have prepared better for this career? And then what would you do differently leaving this pandemic in both in your science, in your career, in your outreach in the community? How has this pandemic changed you, I guess?
Well, on a little bit of a kind of personal note, I started, being a department chair in the middle of the pandemic. So I started in May.
I love hearing that.
We were in the middle. And so I was dealing with, for the first time, labs shutting down, everyone trying to keep their research going, coming up with a plan. How do we reopen? We've never faced this. So I'm brand new in my job, trying to navigate things that none of us have ever dealt with. So that was really interesting. But I think one thing that I definitely am trying to do now, for instance, I do community calls. I live in Washington, D.C., but obviously I work in Baltimore at Hopkins, and I'm getting involved in just talking to community members, people working in all professions, living all parts of the city, all types of, demographic, socioeconomic backgrounds about science and about how drugs work and medicines work. And it's wonderful, I think, that we're doing that now while things are so urgent, but it's something that actually looking back, I wish that we had been doing, because we actually could have maybe laid some of the groundwork for just understanding of science. I think that we need greater education around science, and that working scientists, active, folks working in the lab, and also our physician scientists, I think that we need to have more of a voice, play more of a role in that education. And we're doing some now, but it would have been nice to do before. So what I really would like to do post-pandemic is keep it going. So we may not be talking about vaccines anymore, things like that we're talking about now, but there will certainly be scientific things to think about. So I would like to keep that energy and this enthusiasm we have for education around science, awareness around science. Let's keep it up.
I think that's such a good point. And, I've been throughout this thing, I've been talking about this shifting knowledge base around emerging pathogens. And we've known this. I mean, in clinical medicine related to emerging pathogens, like we deal with uncertainty, but we forget that, we've so eroded science education in this country. And then on top of that, we expect people to understand, probabilistic, changes with all the shifting data and how, we've really done a disservice by disappearing within our walls of our academic institutions and not being open. One thing that's been a personal lesson for me has been communications through media, which I didn't really do that much before. And through this pandemic, I've been sort of shoved into doing it. And it's been, you often hear this about this, like, oh, you shouldn't talk to the media. You don't know how they're going to change their words. And this pandemic, more than anything to me, has revealed how the importance of scientists and academics engaging with media and engaging with new sources of information, so education out in communities, but to as many sources as possible so that we can get those shifting messages or important basics out in a timely manner.
Yeah, you're completely right. We're not encouraged to, right, in the academic setting. I mean, so for me, the same thing, stepping out, I realized it's important. It's important for me to use my voice, important for people to see me and hear me using my voice. But it feels like, wait, no, I'm supposed to be in the lab talking about something in the lab. Like, I'm not supposed to be out here in the public talking to people or quoted in the newspaper. But I think it's important for people to see scientists. We're like everybody else. We found something we're really interested in, and we mostly want help. And so I think it's important to have that communication. The one thing I'll say too, what you said as far as the education accessibility. So for instance, like, mRNA, right? People are tweeting about mRNA. I love it. I love it as a scientist. I'm like, everyone I talk to is talking about mRNA. But when I have community calls out here, mRNA, that doesn't sound good. I don't like that. And I think, wow, it's part of you. It's part of us. It's how our bodies make proteins. We have done a disservice if people hear the word mRNA and it scares them. You should be taught about that early on. As scientists, we should be talking about these things to the public. So I think there's a lot of work we need to do, definitely, so that, when these things come up in the future, they don't sound so scary. People understand them more. So we've got work.
We do. I feel like we will unfortunately never be out of a job, and not only that, but I think that it's going to be a harder road out of this. I saw there's an IMF study, International Monetary Fund study, that showed that in the aftermath of most epidemics, income inequality increases, whether, so internationally for sure, but nationally, we're going to see tons of gaps develop between our low income countries and communities and middle income communities, and people being hit by what we see in a lot of the global South countries, this idea of a disease poverty trap, right? And I think that we're going to see that. We are seeing that here, where people who end up in hospitals with this emerging pathogen are those who are on the front lines, who maybe don't have the luxury to be able to stay in and go through lockdowns, who are essential workers, and those are the folks who end up in the hospitals. Those are the people who maybe underinsured, who end up with the bigger bills, and it's a cycle. And there is no easy science solution, but it's certainly, I think that we scientists could be better at advocating for better access for the tools and the stuff that we work on, be a voice for that in society.
I agree. And the last thing I'll say too, in addition to everything you said, exacerbation of the education gap, right? That we're going to see seeing. So I think there's work that we can do there, more outreach, more volunteering, more mentoring in our communities. And hopefully we can help with that too. Mm-hmm.
Thank you, Dr. Bumpus.
Thanks.
Thank you. Now we're going to bring back Nathan Wolfe to bring our event full circle.
Mm-hmm. Hello.
Hi. Pleasure.
Pleasure to meet you too. So I really want to ask you what it feels like to have a play written about you, but I'll ask you first about your origin story.
Thank you very much. I mean, I would say my origin story does resonate with some of the rest of the panelists in the sense, and I think for those of you who have seen the play, Lauren does a great job of articulating this. I came from a Jewish background where it was, are you going to be a doctor or a lawyer? Like if you can manage blood, you're headed towards being an MD, and if not, you're going to be a lawyer. And I don't know if it was rebellion, but neither seemed appealing. And I think that the comments about the beauty of science and in terms of being able to address fundamental questions about sort of how we fit into the universe. And another way that I like to think of it is when science does its job, it's a little bit like the oracle. It's a little bit like we have this incredible set of tools where we can ask the universe what's true, and sometimes we'll get an answer, and that answer will be resonant and be true, at least for a while. And I think that that's magic, and that's what I always loved about science. And I mean, actually, one of the things I wanted to ask you, and I don't know if we can go back, do reverse directionality, but I would say one of the things that interested me most was evolution. And I think among the things that are most fascinating, and of course, we're seeing this right now in a way that's fascinating, but also frightening, is the evolution of viral diversity in COVID-19. And I mean, I would say that your work as well seems to be very, very much related to the evolution of HIV in response to drug therapy. And it's, I mean, when we think about this pandemic, and I think this conversation's been great in this respect, most people will think, oh, this is about MDs, maybe it's about virologists or epidemiologists, but this is really about the evolution of microbes. It's about policy. It's about economic inequality. It's about nationalism. I mean, there's every feature that you could possibly imagine is tied into the way that we're responding to COVID. So, and I would say personally, it was my interest in evolutionary biology, which really, I started by doing work on non-human primates. And so I was working in Uganda with chimpanzees, unrelated to viruses. And when I started thinking about viruses in the context of work that was being done on chimpanzees using medicines in their environment, it just, the speed at which these organisms these forms of life evolve was just so remarkable that I thought it was an interesting way to understand one of the basic features of how the world works. So I might also reverse it to you and ask the question of, right, it seems like evolution is such a critical part of your work. Was that something that you came upon, not necessarily being interested in it? Or was it part of what drove you to do the work that you do?
I think came upon it, but it certainly, I think, keeps me motivated to understand the pharmacology, how drugs work, how the mutation of the virus is going to change the response. And I think also making sure we get the dosing right to, mitigate people getting these mutations. So it certainly is central to what I'm doing. And it's part of what keeps me going, that question certainly about, the viruses. It'd be nice if we could kind of get ahead of them and predict these mutations beforehand instead of always responding to them, is what I would think.
We need to get Nita back on for that. But now, of course, we've got the same circumstance, right, where we have the emergence of these variants, which, right, of course, it was obvious that if we were going to have so many people infected with this virus, that would increase the probability that you would get a variant which was, I don't know, capable of more sustained transmission or effective transmission. And similarly, that could potentially be capable of escaping the vaccines, which we've so amazingly discovered. But look, I think for this conversation, among the things that's been so fascinating for me is how many different features, and frankly, not just of science, of economics, of humanities, these pandemics are really not biological phenomena. They're really, fundamental human phenomena.
So is that what keeps you driven to studying viruses? Has that been what kind of brought you there and keeps you there?
I would say, I think I got lucky in my career because I was poised to be studying chimpanzees, which is incredibly difficult science and very competitive science, and frankly, it's very hard to answer questions. Whereas virology, such a small percentage of the viruses in the world we even have any kind of minor glimpse or awareness of. So it's such a fortunate field of study where, as a scientist, you can have the luxury to pursue science in an area which is largely unknown. And I would say to prospective scientists out there, I would be curious if you had the same, view that, there's many different ways to do science, but if you can find a field that you are driven to understand, which is largely not understood and not explored, there's a huge, huge advantage to that, as opposed to the kind of science where you're really tripping over other people and difficult methodology to answer a question. And so, I think it was the feature of viruses that were so unknown, so little was understood about them and their importance, which really drove me. But at this stage, and again, Lauren presented this in the work, which is really about a character that's somewhat based on me, and I should state that it's really not me. But look, the good news, and I'm an optimist, is that at this stage, so much is known about, so much is recognized by the world of the importance of pandemics, that I believe that there will be an entire generation of scientists that are out there attempting to work on methodologies to diagnose, treat, prevent, and address the full range of issues associated with pandemics. So I believe we're at the beginning of a renaissance when it comes to the science of pandemics. And personally, I'm hoping to move on, right? Like I've spent, the past 30 years of my career focused on pandemics, and I feel like at this stage, it's something that everyone's going to know the importance of it. And as a scientist, it's important to, keep moving on, keep moving to the next thing.
So how do we cultivate that next generation? How do we instill that enthusiasm and that sense of purpose about, finding an area that no one's worked in? How do we cultivate that next generation?
Gosh, I don't know if I know the answer to that question. I don't know how best to respond to it. What do you think?
I think whatever we can do to definitely try to spend time with folks. I think spending time with younger people, introducing them to science, talking through at least the way that we've thought about things. Surely they'll come up with better ways, but I think one thing that can really be impactful is just being able to have relationships with people that have actually walked that path. And I think for many folks, that's something that's difficult to do. So I think whatever we can do for outreach and to just be accessible would help a lot, certainly.
Yeah, it does seem like this is going to be, I guess it's an interesting question of like how many of our panelists would predict it, but I would say, right, the number of students that want to study microbiology, virology, vaccinology, that's my young aspiring composer in the background. Oh, sorry, it was the cat apparently on the piano in the background, but
maybe an inspired composer still. Yeah.
Exactly. Hard to know, right? But I think there's going to be look. At the end of the day, you can stop and say, what are the biggest threats to our world? And I think a part of the conversation, it was wonderful to see you and Nahid in the last conversation, is inequality. Like, what are the fundamental threats to humanity? And obviously, pandemics. Nita and I spent the last 5 years going out and talking to CEOs and government heads and trying to say, like, look, this is your exposure to pandemics. It's huge, right? Mm-hmm. We don't have to do that anymore, right? It's now clear. But I think there are a set of threats that the world faces. And I think that this pandemic has revealed inequality, whether it's within the, individual countries like the United States or between countries, as one of the fundamental threats that we face as a species and our planet faces. And I think my sense is that for the young individuals that have lived through this, particularly I would imagine kind of middle school, high school kids and college kids, they're going to be, and I think this is good for humanity, interested in catastrophic risk. What are the things that could really devastate us? And my hope is that there will be a renaissance with regards to, I think, pandemic science and all of its various features will be an emphasis. But I hope that it also, pushes people to focus on climate science and inequality and the other features that really we've done such an amazing job of being able to understand the universe through science and to be able to address these risks. But we also face just tremendous challenges. And my hope is that this will, for the next generation of scientists, that it will be somewhat natural and that they will not be just interested in obscure issues. And sometimes those are fascinating, but also the issues behind some of our biggest, most fundamental problems.
You're right. Yeah, I think it'll be interesting to see how it changes people's point of view and the lens that they look at science through, having, grown up through this, basically. All right, great. That was really interesting. And I guess now we go to the next.
Thank you very much.
Thanks.
Great. We're going to bring everybody back now for Q&A. Great. Jasmine, you mentioned that a question came in through Twitter. Do you want to start with that one? Is there better literacy on epidemiology or global public health in the US because of COVID? Did we forget lessons from HIV, Ebola, etc.? Can theater keep alive this public health awareness? Multi-part question.
Mm-hmm.
Anyone want to start?
Well, I think that I hope to be an optimist like Nathan. But even in a much shorter span of a career, I've seen us learn and forget lessons, including the stuff that we learned from Ebola. There are things that we retain, because, you know, there are things that happen in West Africa. West Africa created a whole generation of physicians and scientists of my generation who were, you know, then in their late 30s, early 40s, who then became like this. They learned this idea of the fact that you need to improve quality of care if you're going to answer scientific questions. Like you cannot answer, and so that was applied to the subsequent DRC outbreaks that occurred, because you took knowledge of how to do clinical trials and you applied it to the next thing. You took knowledge about the importance of international cooperation in creating scientific answers in the middle of an outbreak. You took knowledge about how you needed to prepare those infrastructures in countries with limited resources, so you're ready when an outbreak comes. But there are still things they say, you know, in military, they say you're always fighting the last war, where it feels like we're always fighting the last epidemic, because, you know, after H1N1, everybody had these like pandemic plans and they got put on the shelf. And then when Ebola happened, you know, everybody was focused on these treatment centers for treatment of excellence, such as the one that I run, which are focused on 2 or 3 patients with high mortality diseases. And now we're back to COVID. So I do hope that it brings, certainly I've never in my lifetime thought I'd be talking about variants and test sensitivity and specificity with, you know, people who are not scientists on Twitter, and that's something that's new. And I think theater has an incredible role to play. We've seen that with HIV. You know, an entire generation of HIV docs, the generation before mine, were shaped by HIV, and they were shaped by advocacy, the powerful advocacy around HIV, the advocacy community, and the many ways that it manifested itself. And we need that for equity and for emerging infectious diseases and neglected tropical diseases.
And of course, one of the things that theater does, sorry, Ben-Hur. But you know what I think what you brought up about HIV and its powerful impact across theater for generations is because it tells those human stories. That's theater's superpower, is putting real people that we empathize with and understand and come to know and love or love to hate on stage. And I wonder about that power for the work and the mission of all of your work, and hope that we can encourage artists to continue to use what we do well to amplify what y'all do so well.
I think that's important, not just in the space of the theater, you know, in terms of what the manager was just talking about, how at times sometimes we live in silos and we don't take things that stir vaccine hesitancy, you know. And so in a cultural environment, whether it's through theater or literature, for the scientific inclined to at least use this forum to educate people and to discuss the issues and not dismiss them. Scientists, you know, me included, can sometimes, because we don't live in the community that have some of these concerns, we may not take them lightly. And part of the art is maybe to be able to access and educate people around these issues. I mean, this pandemic has you know, basically bared all the scars of society have about inequities, and you know, there's just fodder for it to be, you know, contemplated around. You can't do that in an infographic, you know, when you treat on science, but you can do that in a play and as a vehicle to also inform, I think, because that's the power of it.
And then I'll just ask a question, which is of great concern to me as a kind of fan of science, but also I know to Aaron and the Science and Society group as well, which is kind of our core question, which is how can we better center and amplify scientists like all of you to the wider society, to perhaps drown out some of that misinformation or that anti-science rhetoric. What can artists or anybody do to help y'all do what you do?
I think more platforms and opportunities to speak, like, you know, this is wonderful, certainly. I think any way that we can bring scientists into situations that are, you know, a little bit different than kind of just academic giving a talk, but where we're really just talking to people about, like we're doing now, kind of, you know, like I said, humanizing scientists, I think are important. I also think that there are probably ways to be pretty systematic about it. For instance, in the communities, to have coffee shop hours, whatever it is, organized, that are just scientists to come in and chat with people and meet with people. So on our end, I think there are things we can do. And I think on the end of people that are, fans of science, giving us ways to engage. Many of us aren't asked to do things where we can really engage, but I think would be willing. So there's work on both sides. I think we can work together on it.
Yeah, I have to agree with what Namanje had said, and also what Nahid had mentioned earlier on, really engaging in these types of opportunities as they arise, and making more of these types of opportunities to really humanize science and scientists, and to be able to to speak to an audience that we may not necessarily always speak to, and being able to just convey the information and messages in a way that's understandable, and to be approachable about science as well.
One question that came in, we heard a lot about professional trajectories and key academic moments, teachers and so on that got you into your science. But one question that came in is about where your human or humane values come from to do this hard and important work. Is that ethos from your parents, from your community, from faith?
For me, family and community, definitely. Mm-hmm.
Yeah, my grandfather was lived in colonized India and fought against the British. Not fought against the British, but in representing Indian business owners' rights to hold independent property and independent businesses, and ended up in jail, or threatened to be put in jail or something. The family myth changes. But that idea of social justice, I think, was something, and particularly, I think, ensuring that that sort of small businesses, small Indian business owners, sort of got that access. And my parents were sort of the same strain. I was a Peace and Justice Studies certificate. I did biology. I'm always torn with this, right? I've always been torn about whether I go into Peace and Justice Studies. As you were saying earlier about, like, you did work with social justice and civil rights, and I was a Peace and Justice Studies person in college. But the thing that drives me, and it most recently is, so there was one of the patients in one of the ETUs that I'd had, it was just this crazy situation where, like, at some point it was so insane where patients would just come in, and before we could even triage them, you would actually sort of, they would pass away because there's just so few people to help. And I remember sort of, in one of these, like, hot, afternoons, 100 degrees and full personal protective equipment, going out to the tent, because you had to build out all these tents because there weren't enough beds, within the Ebola treatment unit. And I got to this old man who was there, and you could tell that he was sort of fading, and I can't believe he had missed him. And I'm sort of getting to him, and I'm talking to him, and I say, "Tell me your name. Have we already, like, have we already taken information on you? Have we sort of, like, logged you in? Have you gotten any care?" And he just kept mumbling, and when I heard what he was saying, he's like, when I said, "What's your name?" again and again, he would mumble something. And what he was mumbling is, he was saying, "I'm no one." And when he sort of saw the recognition of I'd heard what he said, he smiled. And the reason I do this is because he was not nobody. And I think that people die across the world without having been given their name, or the reason or the diagnosis of why they died. And that's the drive, is bringing some sort of just respect and ability for all human beings to live with at least good health and at least die with dignity.
Very powerful. A question that I got from an email. So where and how can we see The Catastrophist? Lauren.
Sure, I will answer that one. But I know we're coming to the end of our time. And before I do, just an incredible, heartfelt thank you to all of you for sharing not just your stories, but your passions, your purposes. It really is absolutely breathtaking. And I'm so grateful for your work in the world. and know how inspired so many are because of what you do. So part of that inspiration sometimes turns into art, which is part of the reason we're all here. So the play, The Catastrophist, you can stream now. It's at marintheater.org and roundhousetheater.org. It'll be streaming for a while. So check it out and have a conversation with folks in your life that you think would be excited about a play that's about the person behind the science, and it's about love and loss and discovery and resilience and a lot of things that I know I have felt during this time. A very personal story, but also, we hope, a very universal one. So marintheater.org and roundhousetheater.org. And yeah, thanks for watching.
Thank you. I think this is a great wrap-up question that came in. What's an easy thing non-scientists can do right now to become more science literate or grow our interest in the sciences?
I think you can watch a play about science. If you have a suggestion, perhaps I might have one. But there are also, there are so many great plays and great novels and great biographies about scientists. As a non-science person myself, part of my love for the science came from those, and came from so many avenues. Films about science. Nathan and I just saw that film, The Dig, about archaeology and anthropology. And so there's a lot of ways that you can just add more science to your life through plays and books and screens. But I'd be more interested in y'all's answers.
Ben-Hur, what were you going to add?
No, Lauren took the words out of my mouth, because out of find a book. People have different interests, but science never ending in all its glory. It doesn't have to be viruses. I'm not selling Nathan's book, Viral Storm, but my student just told me that it became me feel old, that when he was in grade school, you read your book or whatever. But find a book and it could be Rosetta Stone. I mean, it's the journey of discovery. I think if you get that sense of excitement through it, that's important, and that will lead you on further.
I'll just add one thing that always helps me put things into perspective. Watch The Pale Blue Dot by Carl Sagan. If you ever want to find your place in the universe, it's a good place to start in terms of orienting where we are in the universe and how small.
And one also thing is to follow scientists on Twitter, on Instagram, on Facebook. So many of the people that you see here have incredible, very informative, also very funny and human feeds. So you can learn a lot kind of in bite-sized, scrollable fashion.
Great. And one thing I'll add is for our audience to be on the lookout for our next event that's in conjunction with this one. So here we brought in amazing scientists to talk about the stories that got them into science. In March, we're going to bring in storytellers who cast science and scientists as center stage in their work. So Lauren will be joined by some wonderful peer writers and other storytellers of hers. So be on the lookout for that announcement. And so we've hit our 9:30 Eastern, 6:30 Pacific mark. So I just want to thank all of you again for sharing your deeply personal and human stories that got you into the amazing and impactful work you do on behalf of so many communities in the world. We're so grateful for what you do. It's really hard, and just thank you for doing it. And we're going to bring on our two other folks from the theaters just to say a quick thank you. Jasmine.
Hi, everyone. Yes, on behalf of Roundhouse Theater, on behalf of the whole arts community, really, thank you for the work that you do. And thank you for sharing your beautiful stories with us. It's something I joked about with Lauren earlier, but I think any one of you could be the next Catastrophist, right? Could be the next play that we see on our stages. So thank you for all that you do.
Hi there, I'm Nikisa.
Thank you for having us.
I'm Nikisa Etamad. I was the producer of The Catastrophist, so this project is very close to my heart. And also on behalf of Marin Theater Company, I want to thank you. You are great minds and pissed off people with a mission. That is now my new label too, because I feel that way. And I just want to share that my father is an Iranian aerospace engineer. He's called Mr. Apollo in Iran. And his inspiration came from reading Jules Verne in French translation as a young Iranian engineering student. I just want to say thank you again and encourage people who are watching tonight, please check out The Catastrophist. I think it's a celebration of science through the mind of a scientist, and you can see it at either one of our theater companies, and we'd love to share the work with you. And scientists, keep doing what you're doing. We need you so much in our lives. Thank you so much.
Thank you for having us.
Thank you.
Thank you.
Thank you for
Thank you
having
all.
us. Thank you.
Good night, everyone.
Bye. Good night. Nice to meet everyone.